In this video, we'll look at the intersection of a line and a plane. So there's a line, it's the r vector, and it's given by 3, 2, negative 1, plus a t, 4, 3, 2. So this is really the direction vector, and this you can consider more of a point. It's like a point plus a direction vector to have a vector equation of a line. And then here's a plane in 3 space given by x minus y minus 2z equals 0. There's a scalar equation of a plane. So the first thing we're going to do is let's change the line to parametric. We're going to change it to parametric equations. And that's just reading this point. Again, think of this more like a point plus a direction vector. So we can say the x is the result of taking the starting x value, 3, and adding on 4 times whatever we pick for t. And we could say the y value is just the starting 2 value plus 3 times whatever the t we choose is. And finally our z value, which is start at negative 1 and add on 2 times whatever we chose for t. That's step 1. We've changed the line to parametric equations. Next, we're going to sub the line. Let's call the line parametric equations. Let's call this, I don't know, 1a. Just calling it 1a because I like to call this here. I'll put the 1 here. This is equation 1 of the line. And so 1a, it's been adjusted. It's the same as 1, but I've changed it somehow. In this case, made it parametric. I'm going to sub 1a into the plane. Let's call that equation 2. I'm going to sub 1 into 2. Sub the parametric equations of the line into the plane. So replace this x with this parametric 3 plus 4t. And why are we doing that? You don't need brackets. I'm just putting it so it's clear that's the x. We're doing that because wherever these intersect, both equations have to be true. That is, this equation and this equation have to be true. So this x has to be true for this x. In other words, 3 plus 4t can go into x because it represents the same spot if they indeed intersect, which we hope they do. We'll find out. Meanwhile, the y, that was minus 2 plus 3t. I definitely need a brackets there because I'm going to rainbow that minus in. And finally, minus 2z. Again, the z is negative 1 plus 2t. Also need a brackets because I'm going to rainbow or distribute that negative 2 in. And now I've got an equation. So let's solve. Let's see what we get. I get 3 plus 4t. Just drop the brackets. Rainbow or distribute this minus. That's minus 2 minus 3t. And rainbow this negative 2 times negative 1. You get plus 2 minus 4t. Still equal to 0. And let's collect like terms now. Start with the t's. I got 4t minus 3t minus 4t. It's nice as 4t, take away 4t is 0t, take away 3t. Just leaves negative 3t. And now the like terms of just the constants or the numbers. 3 take away 2 plus 2, also convenient. The minus 2 plus 2 cancels out and add 3. You get negative 3t plus 3 is equal to 0. So of course we want to solve for t. We'll get the 3 on the other side by subtracting 3 both sides. And you're left with negative 3t equals negative 3. And finally, do the opposite of what's happening to t. It's being times by negative 3. So we divide by negative 3. And we get t equals 1. The fact that we found a unique t means that there is one solution. Therefore, we know there is one point of intersection. There couldn't be 2. There could be one point of intersection, or there could be a whole line of intersection. That is, this line could lie on the plane. But because we found a unique t, if we got any individual number for t, it means there's one point of intersection. So now what do? We just find that point of intersection. So let's sub t equals 1 into the parametric equations, equation 1a. That is, we'll find out what x, y, and z are, that point of intersection, by finding out what this t is. This t tells us the point of intersection is when you set t equals to 1, you get the point that's both on the line, on the plane. Let's find it. X equals 3 plus 4 times 1, which of course is just 7. And y equals 2 plus 3 times 1, which of course is 5. And z equals negative 1 plus 2 times 1, which is 1. Didn't need a calculator. And so I've got my point of intersection. Therefore, the point of intersection is, and we write out the coordinates in order, x, y, z, 7, 5, 1. And that's it. We found the intersection of a line and a plane. We started off with a equation and of a line and an equation of a plane. We changed it to a parametric equation, that is, the line became parametric. We subbed those parametric equations into the plane's equation and solved. And since we got t was a unique integer, just a single integer, that meant there's one point of intersection. This line and plane cross at a single point only. So we sub t back into the parametric equations to find the answer, and we got it. The point of intersection is 7, 5, 1.